We'll have a quick chat up here about where we're at and where we're moving to with this folio task. So far I think we've defined mosquito A and mosquito B in their path and their speed and where they're going to and how fast they're traveling and so forth. Okay. If you haven't done so yet, one calculation I do want you to do is the shortest distance between skew lines. So we have mosquito A has some line 1, mosquito B is some line 2, and we can think of these, I'm going to use my arms, we can think of these as like their paths are like this. And when we, in exercise 6G.3, we did what's the shortest distance between their paths. Now this is a good calculation for us to do because in a folio we want to demonstrate as many skills as possible. That's what we're trying to do, demonstrate lots of skills. So we're going to do that calculation and then we're going to reflect on that calculation and say, but this calculation is not particularly useful in our circumstance because we don't want to know when their trajectories are closest together. A mosquito is a point traveling along that trajectory. We want to know when are the individual points that the mosquitoes occupy, when are they closest together. So we're going to do the shortest distance between skew lines and say this is a calculation that demonstrates skills, but it's not useful because we want to know when are the mosquitoes, the individual points closest together, which we did in the quadratic time calculation. Okay, so it's like, it's a refinement. We've defined mosquitoes, found the distance between their paths, not useful. Okay, let's find when are they closest together dependent upon time. All right, and that's sort of the basics of part 1 and 2. Then what we're going to do is we're going to reflect on a number of ways that we can kill those mosquitoes. So I'll talk about a few processes that people have tried in the past and done really well in the past. The first is a salt gun. So what that is, it's a little gun that shoots packets of salt. All right, and so what you're going to do is you're going to define, let's talk about each one. Let's say you're doing the salt gun. You're going to define, here's the gun, and I want to shoot the mosquito when it's here. So one thing we're going to look at is, well, how fast does the salt travel? Okay, so it might be, all right, I'm going to shoot the salt and it travels at 50 meters a second, but by the time it gets to here, mosquito A has moved a tiny bit that way. Okay, so that means we need to anticipate when is the mosquito going to occupy that position such that the salt hits the mosquito. All right, and then the same thing with mosquito B. It's got its speed that it's traveling at. When is it going to arrive at this position? So we need to say, all right, it's here, and mosquito A is here. I'm going to shoot the salt. It's going to hit this one, hit the second one. Okay, and that's not too tricky a problem to define. We just have it's a line. It's a line that we define. Another student, one thing they did was a grenade, an exploding like bug spray thing. And so the way that they modelled that is they said, I'm going to chuck a grenade halfway between them, and it is going to be modelled by an expanding sphere. And so you can think of like this sphere that grows outwards. So it has a rate at which it grows outwards. And we can define a sphere in 3-dimensional space with like a radius, you know, so you might say its radius is at least the distance between those 2 points. And you can even have it such that it reaches its full size when the bugs are arriving into the sphere of bug spray. So we have a grenade. The most common one people have done is spray, all right, and that might be a bit better than a gun to model, okay, because we don't need to so much consider when is it going to arrive at that position. Rather, what we'll do is, you think of spray. Spray is a cone, all right? And so we're going to have some normal over which the spray takes place, and then we might have this at 30 degrees or something like that. You can research that, so that the spray is going in this direction. And obviously, the spray is most concentrated here, and the concentration of the spray dissipates towards the edges of those vectors. This is a cone, so it's 3-dimensional. And so again, you're anticipating when is mosquito, you can anticipate when is mosquito A going to be here, or you can say, I'm going to spray it when mosquito A is here. Mosquito, this is the shortest distance between them. Mosquito B will have travelled this much. I can perform those calculations based on how fast the spray travels, at which point where is mosquito B in relation to the cone, and is it going to suffer the effects of the spray? All right, so there's all kinds of things that we're going to research here. We define a point that we're spraying from. We define how fast the spray comes out, how far it travels. All of these things you can research and find online to help you with the reasonableness of your results. Okay, so that's spray. And then the last one is a SWOT. And a good way to define a SWOT is that a SWOT is a plane. Okay, so remember, we want to demonstrate lots of skills. We don't just want to do lines over and over and over again. So a SWOT is a good one. We can have a plane traveling through space. Okay, and so we have the equation of a plane, and then its position with regards to time changes accordingly. So one simple way to define a plane is restricted by, we can have 3 points, we can have 4 points. 4 points, and you can think of each point as a line. Okay, so if the mosquitoes are within these points, then they're going to be collected by the SWOT. Yeah. So all of that can get a little bit complex, but it's going to be stuff that I'll be helping you out with. But that's the direction we're going. I think so far hopefully we're sort of getting that done. We've done that part, and so we're ready to start reflecting on these and performing these calculations. Okay. So what I'd like you to do between now and Tuesday, then Monday will be our next lesson, is have a go at maybe trying to model one of these to start with. Okay. So just come up with some numbers, and I've filmed that again so you can